Good morning, eights. So your assignment today is about lines of best fit, or really, we've learned about these families of functions. And at one point in the year, if you guys remember in this assignment, we talked about lines of best fit, really. So this was a line of best fit for the data, and it doesn't fit very well because this data is exponential. But one of the things we see when we look at a line of best fit is that whatever your data looks like, about half of the data should be below the line of best fit and the other half should be above it, because the idea is that the line of best fit should go through the middle of the data, hence splitting it in half. So today we have a couple different steps to it. The aim up here, I was thinking you just put your name. I wasn't thinking an aim at all, but a line of best fits. Come on, can be used in bivariate data. When we say bivariate here, we mean two variables. So just saying we have arm span and we have height. There are two separate variables, but we have bivariate data, and a line of best fit would describe the relationship between that data. This line is also has a different name. I'm sorry, I know the highlighting is moving and that's annoying, but the different name is a, come on, trend line, because it captures the trend of the scatter plot. Basically, this scatter plot has an association or a trend, and so when we look for it, when you look for that line of best fit, you're trying to define the trend that occurs between them. So let's look at some examples. Students in our class are learning to make realistic drawings of people. As part of their work, they investigated the relationship between height and arm span. They collected data from several individuals, and you can see that they scatter plotted their data. So if we draw a line that best fits this data, this line, for example, would be a bad example because it's like entirely above the data. This line also, like, I might be able to get about half the data above and half the data below. No, that's still somewhere near there. I could have like half the data above and half the data below, but it also doesn't match the gradient or the slope of the data. So those are the two things that you have to keep track of. Try to match the gradient or the slope of what's happening, and then try to split all of the data points in half. So we actually want, like, what's pretty obvious, but a line that's something like that. It actually matches the slope of the data, and it splits the data in half. And then we could look at this line, if it didn't move like that, and we could come up with an equation for it. I could look at how fast is this going up and over, and that would give me a slope or a gradient for it. And we could find a y-intercept as well and have an equation. So your first problems here, eights, you're just doing exactly that. You're trying to say, like, which of these trend lines is better and why? Great, well, that's pretty obvious. Down here, which of the trend lines is better given the data? Look at those two things. You want to match the slope of the data, and you want to go through the middle of the data. So you want to have about half of the data above and half of the data below the line. While you try those, go ahead and pause the video, and then once you try them, start it up again, and we'll do the next one together. All right, eights, so I'm assuming you have tried those, and you're here and you're back. So let's look at this. This is where we're going to do the whole thing ourselves. We're going to draw a scatter plot, and we're going to write the equation for the line of best fit. So let's start out just scatter plotting this data. To scatter plot, we have advertising, number of listeners when it reduces the time used for advertising. So they're saying they have less advertising time per hour, then more listeners probably, which is interesting. Oh yeah, we do see that trend. So let's go ahead and scatter plot it. Well, I would put advertising here because it seems like that's the independent variable that's causing the number of listeners to change. Come on, and that means I would put number of listeners over here. And I know I didn't leave you tons of room here. But so then we need to label this. Well, our advertising dollars goes up to 26, the highest. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marks. So I'm just going to say, I'm going to make the top 30 here. So 1, 2, 3, 4, 5, that one's 15. And then I can go and label all of these, but you can see it's just going to get really messy. These should be all labeled, starting at 0 and going up to 30. I just don't want to make it super messy, so label your axes. Then on this axis for listeners, we need to get at least to 400. I assume it's another 10, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're counting at least by 40s, or 42s really, which means I'm just going to count by 50s, which means the top is going to be 500, the bottom 0, 50, 100. You can do that, but fill in your axes. So then let's go ahead and scatter plot this. We've got 26 to 40, so 15, 18, 21, 24, 27, 26, and 240. So that's 100, 250, 240, somewhere around there. Maybe I should use bigger dots. Okay, 21, 180, 15, 18, 21, 180. If this is 200, 180. Sure. 18, 280, 18, 280, 280. Yeah. 16, 300. You can go ahead and like scatter plot your own and then just skip forward in the video to where I'm done with this. 16, 300, 16, 300, 14, 410, 14. So that was 300, so 410, 12, 420, 12, 420. So we can definitely see in this data that the more advertising minutes, the less listeners, which makes sense. The advertisements are annoying on the radio. But if we wanted to actually write an equation for a line of best fit, well, first I need to approximate that line of best fit. I can see it going through here. We've got 1, 2, 3, 4, 5, 6 data points. So I want to get about 3 below and 3 above. And I think I'm going to split it right like that. So because I'm looking at trying to make sure I match the slope of the data and trying to make sure I have half the data above and below. That looks pretty good. Maybe, well, that looks pretty good. So then to come up with an equation for that line of best fit, well, we know lines always have like a gradient times x plus a slope, or so plus a y-intercept. So those are the things we need. When I look for the gradient, I would be looking for places where the line goes like the closest to the crosshairs. So here we're like really close to the crosshairs, and here we're really close to the crosshairs. Here we're really close to the crosshairs. I would choose those spots. We can see that our slope here is not exactly, this would be down 50 over 3. I should write this. Well, whatever. Slope is, that's down 50 over 3, which is about negative 12 and 2/3. We could round that. I mean, this is data. We're dealing with approximates already. I think this is going a little bit slower. Yeah, I can see, because here it would be like down 50, down 50, down 50. It's actually going slower than that. So because this is going down slower, I'm just going to call this like it's approximately equal to negative 12. Good. Then where would that y-intercept be? Well, here we're already back at like maybe 5. And so if this is at 500, I can think if I go back 5, I'm going to go up 12 times 5. So back here, this would be back 5 and up 60. Meaning that we would end at 560 right there. So overall, now I have an equation for a line of best fit. I have y equals negative 12 was that gradient that we got by looking at the points that were near the crosshairs times x plus the y-intercept, which I could go back and resolve. It should be near 560 up here. I'm definitely approximating these things, but it's kind of nice because now you guys have seen we can approximate this type of thing by hand, and we get an equation for a line of best fit that is approximate. It's probably pretty good, but it's definitely approximate. Or we can go and use technology and we'll actually find the line of best fit, and we will definitely talk in the future about how this works and does what it's doing, because it is not estimating the same way we are. But these estimations are decent, and we don't need computers to do them. So go for it. Try these out for the rest of it, and I will talk to you soon. Best of luck, aides. Bye-bye.